Hi, in this second VHDL presentation we will start to look into register transfer level combinational design. And by register transfer level we mean the use of intermediate sized blocks such as headers or multi-bit registers, so we will not be talking about single bit gates. More specifically in this case we will start by looking into operators and data types. Now, after watching this presentation I hope that you will be able to list what are the most common VHDL data types and to relate data types and operators. And let me call your attention to the fact that we will focus on the initial part of chapter 3 of our recommended book. Now, in addition to the logic operators, there are other operators that correspond to intermediate sized blocks. As we have just said, headers and eventually comparators are good examples, and which can also be synthesized automatically. Now, one key aspect that we must be aware of in order to use them is what data types they can be used with. What we see here in this slide is the correspondence between operators and data types, that are defined in the IEEE Standard Logic 1164 package. I will not go into the detail of reading line after line because that would be too boring for you, but this is the type of table that you will need to come back frequently to during your design work in order, for example, to check if a given operator can be used with any given data type. Notice, for example, that multiplication, the second operator here, cannot be used with standard logic vector or standard logic data types, which we used before with the logic operators. So actually the multiplication operator can also be used with the signed or unsigned data types, but these are not defined in the Standard Logic 1164 package. So if we need to use signed or unsigned data types, we will need to include the numeric standard package in our design as well. Also, please notice that the result data type is not necessarily the same in the case of the as the operands, as you see here in the case of the arithmetic and relational operators. So in the arithmetic operators, the result data type is unsigned or signed, so it could be the same as the operands. But in the case of the relational operators defined here, the output is of data type Boolean, so it is of course different from the inputs. There will be cases when we need to convert from one data type to another. For example, if we have an arithmetic multiplier block that has inputs of the type standard logic vector, for example, then we will need to convert from standard logic vector into unsigned before they can be multiplied, and then the result will need to be converted back to standard logic before being sent to the output pins of the circuit. So in this case we would need to go from standard logic vector to unsigned using this conversion function here, and then before outputting the result we would need to convert from unsigned into standard logic vector using this other conversion function. Again, let me recall that you do not need to know all this by heart, but these rules play a fundamental role in every design and are actually frequently the reason for errors and mistakes. So please look carefully at these three tables and read the corresponding sections in chapter 3 of our book. and you will then be much better prepared when you need to come back to these tables during your design work. Thanks very much for your attention.